Welcome everyone to this evening's events on graphs and graph learning and graph analysis. I will confess that I am essentially in the exact same position as everyone else who's come here wanting to learn and not knowing a lot about the topic. And that's why we're really lucky to have our experts in the field here tonight. All of whom I had written up elaborate bios for, which I don't even have to read now based on the conversations that we had earlier, or I suppose I could whip through them since for posterity, because we're recording, okay? Because there will be people attending this event after the fact. So we have three speakers this evening. Nabila Abraham, who is a data scientist at Loblaws, focused on research and development, particularly in the health and wellness space and identity management. Prior, she worked at the Lunenfeld Tannenbaum Research Institute at Mount Sinai, creating 3D computer-aided diagnostic algorithms for retrospective prostate cancer detection. Nosheen Fatma is an applied research scientist working at Crater Labs, which is an industry-leading Toronto AI and machine learning research laboratory. Nosheen has significant experience with graphs and machine learning, including a master's thesis that is focused on deep learning through the use of knowledge graphs. And we have Karim Khairat, who is an expert on graph neural networks with significant teaching experience on the subject, including right now leading a training course for aggregate intellect on the topic. He is an ACE stream owner on graph neural networks, who also has a distinguished career as a data scientist in the international financial services industry. So welcome all of our experts. Thank you so much for coming. And I think maybe just to kick things off, as I mentioned, a lot of us know graphs have to do with a way of keeping track of relationships, billions and billions of relationships in some cases, but some of the details may feel a bit more obscure for people in the audience, and myself included. So why don't we start, Karim, why don't we start with you and ask, what are graphs? Why are they important and useful in machine learning?
Thank you for the overly kind introduction. So basically, a graph is a set of nodes, right? Just vertices or nodes or whatever you call them, and with some interconnecting edges or links between them, right? And so nodes can represent many things, right? In a social network, a node can represent a person and their attributes or their information. In a knowledge graph, a node can represent an entity, right, and its information. And the links represent the relations between these nodes, right? So in a social network, a link can be like a friendship, right? Like a friend, or on Twitter, it might be a follower, on other kinds of social networks. And also in knowledge graphs, links can be like how these two entities are related. For example, like let's say Barack Obama is an American citizen, right? Barack Obama is an entity, America is another entity, and the edge between them can be citizen of, right? So this is general. So edges basically capture relations between objects, right? And nodes can be objects. And it doesn't have to be something that's very obvious to us, graphs don't have to represent actual physical networks that you see in real life. You can have in machine learning problem, you have a lot of data points, right? And every node, for example, can represent one of these data points, right? And edges can represent data points that are similar to each other, just like an k nearest neighbor algorithm, right? First step is to create a KNN graph, right? And that's already a graph, and where the objects are your data samples, and the edges connect between them. So you can also, these are kind of information networks, right, from your data as well. And yeah, so these are graphs. Graphs are a very general data structure. In general, they're very general. They can capture a lot of data structures that we already think of. For example, an image, right, is a graph, right, where every pixel is a node, and every neighboring pixel, right, will be is the neighbor of that node, right? So it's like a regular graph where every node has in 2D 4 edges, right? Top, right, left, and bottom, right? So graphs basically represent images. If you have a time series, right, you have like one point and followed by another point, followed by another point, and so on. There's a sequence of points, right? And this is like a 1D graph where every node is just a node and an edge is connecting, edges are connecting subsequent nodes, right? So these can also be presented as graphs. And then you have, graphs representing more complicated objects, right? Where every node can have many different neighbors. Some nodes might have no neighbors, can be isolated nodes, and so on. So graph in general is a very general data structure, right? That can represent a lot of objects. I would say it's like the most flexible data structure that you can have, and it's ubiquitous in all of computer science, right? There are many graph algorithms, even forgetting about this graph neural networks, graphs have always been there and they've always been used. So I think it's important to also know how to use graphs just for, for your own development as a data scientist, right? Because it's just a very basic building block in many algorithms.
Okay, great. Nabila, based on your experience and perspective, do you have anything to add?
Kareem's answer is very comprehensive. You took all my points, so I have nothing left. But the short version is graphs are useful. You can model any data set as a graph, be it images, text, sentences, time series, whatever. But the strength of it comes if you know for a fact that there's inherently some connectedness in your data set. Like for the most part, if you're a data scientist in healthcare or finance, you have image data, but traditionally you have relational data in something like SQL databases. And the challenge is people find that, oh, my data is already in a database. It's already structured as RDMS or RDBMS, whatever. So why do I need to make this leap of faith to the graph structured world? And the reason you may want to do that is because if you treat your data as sort of row based, not creating edges between them, you are cheating your model of structure that it could use for its predictive tasks. So when you model your data as graphs and then you push it through a graph neural network, the strength of graph neural networks then can be used to sort of lessen the onus of the network to learn structure because you're giving it structure in its data in the graph data structure, if that makes any sense. So if you can model your data set as a graph, it's very useful, especially if since many tasks have these sort of connected component structure. It's not a I wouldn't recommend it for every problem, but there are problems where graphs are very beneficial over the traditional methods.
That's great. Now, Sheen, what's your perspective on this?
Yes, I think both Nabila and Kareem has spoken a lot about like what graphs is and where it can be used. The only addition I would add is like, okay, the graphs can be of like two categories broadly. Like one is your homogeneous graphs where all your nodes are of the same type. So let's say you have something like a Google map graph where everything is a place, your every entity is a place. Like you can also represent it in a knowledge graph or a heterogeneous graph, but yeah, where every node and a relationship edge is of same type. And then there are like heterogeneous graphs where every node can have a certain type, or every relationship can have a certain category or type. So yeah, I mean, depending on the application, I mean, you can have different type of graphs.
Okay, great, great. Based on what I understand, machine learning models that use graphs produce better results than those that don't. Is that true? And why is that? Maybe this is a math question. Kareem, what's your perspective?
Right. So in the power of using graph neural networks is that they take into account relations between objects, right? So coming back to nodes and edges, right? If you treat a node as an isolated node and just try to predict something on that node, be it do a regression or classification task, using the features that you give to a particular node, that's the traditional, machine learning tabular learning problem, right? But you're not taking into account any relations of that data point with other data points, right? So if in your application that is important, those relationships are important, right? Then a graph neural network may improve your result, because basically you're not treating a data point in isolation, but you're treating this data point as part of other data points that may be related to it and that can improve your prediction. And it doesn't have to be a very sophisticated model in order to capture those relationships, right? You can basically just take like the average features of the neighboring points of your graph, and then just do pass that on to a traditional classifier, and you might get better results doing that already. And there have been papers that show that just doing something simple like that can help you improve the results.
Okay, that makes a lot of sense. Thanks. I wanted to ask you guys about examples. Some of them have come up already, but examples of the application of graphs in machine learning. Maybe I'll ask Nabila if you can think of maybe a particularly interesting application of graphs in machine learning, and maybe even one that people may not have heard of.
Sure. So I'm in kind of in the health space. So the things that I investigate graphs for are graphs for health. And one of the things I'm interested in doing, and one of the projects I'm involved in, is how can we use graphs to treat disease progression or stuff like that, about forecasted disease. And those are kind of relationships that are not necessarily linear. Just because you visited a doctor once and you visited him a second time, you shouldn't treat them independently. And yes, there are ways you can treat them right now that are non-graphical that do to some extent take this into account. But they don't take into account every single feature in a record that is related, that could be relevant to your disease progression, that could be related to what you're trying to forecast. So that's kind of an application or an area I'm interested in. And there are some works that try to show how we can use graph neural networks and your patient record data to track your disease progression. Now, what's interesting in some of those works is that graphs are kind of transparent in the way that they'll make their predictions, in that you can investigate how nodes are connected to other edges, right? Because you've given it that and you ask it, can you learn some sort of attention coefficient on these edges? And at the end of the day, when you make your prediction, now you can investigate why did you make this prediction of Alzheimer's disease based on all the nodes that are in my graph. And a patient graph can be nodes like, I went to the doctor, he drew some blood, that's a node, because everything in Canada is inherently coded by these disease codes or uh, lab treatment codes, stuff like that. So it's actually inherently graphical in nature anyway, so it makes sense to take advantage of it for some of these medical tasks. And some of these works you can trace back and find out, why did you forecast this disease? It's because of this node, this node, this node connected in this fashion gives you this output. So it can be transparent in that nature, and useful for healthcare, especially when you don't essentially know what your input feature space should be for the certain task. It's kind of like a discovery algorithm for a lot of medical tasks.
Oh, that's really interesting. I mean, often we'll talk about neural networks as being like black boxes, but it sounds like there's a real element of explainability there.
Somewhat. There's like, if you go with the route Kareem suggested, the simplest graph convolution method, where you kind of just average what your neighbors are saying about a certain like, you take your neighbors' node representations and you average them together. You haven't learned anything. You've just taken an average. So in that sense, it's kind of transparent because you could backtrack. But there are more complicated methods that you could use that are essentially like learnable parameters. So not exactly explainable in that sense, but there is a good concept of transparency in that you can look at edges and try to understand better how the model came to its conclusion.
Right. Cool. Cool. Nasheen, do you have an example of a particularly interesting application of graphs that you could share with the group?
Yes. So in my previous work, so I was working in a recruitment company. So we were building like knowledge graphs for recruitment. So the reason was that there was a lot of, I would say, ambiguity within the data there, and multiple representation of the same thing. So let's say a person comes, a candidate comes, and he uploads his CV, and then what happens is every person has their own way of writing things. So somebody would write, IBM, somebody would write, International Business Machine, somebody would write some other thing. And similarly for a skill, like somebody would write, a Java programmer, or a person would write, a software developer. So how do we like identify that all these things are same real world concepts? So like identifying, okay, this is a unique concept or this is a related concept. So how do we build a graph for that, which can help us in suggesting better things for our platform users? So let's say I have come here to search a job, let's say Java programming job, and let's say in my current data, I don't have exactly Java programming, but I have a different synonym. So how do I uh, link the query to a graph of a unique unique concept, or a real world concept which means the same thing? So I think that was pretty cool.
Okay, cool. That's great. Now, Kareem, my understanding is that based on the highly regulated field you're in, you can't necessarily provide interesting examples from your own career. But I know that one of the things, I've looked at some of your training materials, and I know that one of the examples that you had mentioned was in the pharmaceutical world and drug side effects and that sort of thing. Could you maybe speak to that example for the group?
Right. So I'm not an expert, but I'm just conveying that example, right? So in drug discoveries, right, you need to know how a drug acts on a certain protein in your body, and there are certain drug interaction side effects. So you have, first of all, you have two graphs, right? You have a graph where different drugs, right, have side effects, negative side effects on the body when taken together, right? So these nodes are the drugs, and the links are the side effects when the drugs are taken together. And you also have protein interactions in the human body, where you see how the proteins interact with each other. And these graphs were basically created using human knowledge, or specialized knowledge in that field. And you also know which protein a drug interacts with when ingested by the body, right? So you have these three kind of edges, drug edges, protein edges, and drug protein edges. And an interesting task was to find out, okay, like let's say we have a new drug, right? Can we predict if it's going to be have a side effect when taken with another drug? And in the paper, I can look it up now and provide the reference. So in the paper, they provide some examples where they predicted, right, some top candidates of drug side effects of taking two drugs together, and a lot of them were actual side effects when they tested them. So this is something that can accelerate research, right? So that's a great example where this has been used to accelerate research, and probably in reality doing this is very difficult. You just have to wait for people to take two drugs and get a bad side effect, and then they get recorded later. So just having a tool to predict possible side effects, right, can save is very important for the pharmaceutical industry, and I think that's a very cool application.
Cool, that's great. Thank you. Now, I know that people who've come here have questions for you guys. Before we break out into some conversations individually here, I wanted to pivot for a minute and just, there's a question I always ask, and you guys haven't been asked yet, but some of the people here have heard it before, but the answers are a little bit different. It's about ACE and about your involvement in the organization. I want to go around to each of you, maybe starting with Nausheen, and just ask a bit about how you came to be involved in ACE and how does it benefit you? What do you enjoy about being part of the organization? Because we want other people to get involved too.
Yeah, so I mean, last year when I immigrated to Canada, so I was looking for, networking and like-minded people in the industry, and uh, just having a group to have a discussion and maybe looking for mentorship for newer place and a newer environment. So there, I the first event I attended was a women in AI event. So there I attended just for interacting with people and getting to know each other better. And also, at that time I was looking for jobs. So yeah, I mean, I was trying to see that what people are there in the industry and what kind of work they're doing. So yeah, that's how I started. But I started liking it more, so I started attending it more. Uh, so uh, so yeah, I mean, and when we went like completely online due to COVID, so I think I missed those personal visits. So I think to force myself to be involved, I started with the presentations and getting involved as a stream owner to keep myself more active in the community.
Okay, great. Nabila?
As Nasheen was talking, I remember meeting you at the Women in AI social, I think.
Oh, all right.
I feel like I've seen you there. So I guess my ACE story is the poor academic. ACE had really good pizza a couple years ago, and it's a running joke how everyone joined ACE for the free food. Um, but yeah, I did join ACE. I started attending events at the tail end of my master's, so last year, like May, something like that. And it was because I was like, okay, I'm transitioning to the industry, and people say you lose brain cells when you go to the industry because you're always doing logistic regression. It's not the case, I've learned, but this is what I heard. And so I was like, I really want to get involved with some academic groups so I can keep that bridge open to academia. And so besides the really good square pizzas, they had paper discussions in person with lots of people and lots of good questions. I thought, like we used to do sort of like journal club events at my school, but getting people to ask questions was hard. And when I got to see people's questions at ACE, I got to learn a lot more. And so that's when I sort of joined ACE. I actually got recruited at the Women in AI Social, so it's a really good networking opportunity as well. I encourage people to check it out. I forced myself to go there, and by the time I got there was no more Indian food, so I was very discouraged. But then I got hired, so there was that. And then shortly after I got hired at Loblaw, I heard about graphs and I went into this graph neural network rabbit hole. And I was like, Amir, you should start a stream for graph neural networks. And he's like, here's the application. Why don't you do it? And it was quite scary because I was just getting into the field, and I still relatively new to the field, but that's kind of why I got in, to kind of force myself to read a bit more, to learn a bit more. And the whole online thing kind of didn't phase me at that point because ACE was doing a lot of online events, and it's just a better way to ask questions. You don't have to worry about putting your hand up and people turning around to look at you while you have pizza in your hand. So I think I joined ACE to just get to connect with academia, but more so to connect with the community, because learning with each other is a better way to learn than just being siloed.
Yeah, that's a great point. Thank you. Kareem,
Yes, sir.
talking about ACE and your involvement and how amazing it's been for you. And
Oh, yeah.
And how much pizza did you eat?
There's that,
Oh,
yes.
I ate all the vegan pizzas that were there. Anyway, so, yeah, I think around, was it 2 years ago? I think we're no, 2.5 years ago, I moved to Toronto, and I was mainly looking for a job as a data scientist or quant at a bank. And I was just joining any meetup that popped up on meetup.com, and then there was this TMLS, Toronto Machine Learning Series. At that time, it was mixed with also TDLS, Toronto Deep Learning Series, which was precursor for ACE. And I went to these, so I went to any event just basically to get recruited and get a job. And yeah, and I asked, I think at one point, Mir, if I can present this paper on graph neural networks. It was graph attention networks, and that's my first contribution to ACE. Basically, at that point, they didn't have a lot of authors presenting, but they had community members presenting papers. So I got in before that door was closed, and now we have the actual authors presenting. So it's a lot harder now. And yeah, so that's how I got involved with ACE. And after a year or so, I became also the GNN stream owner, right? And also was asked, if I'm interested in creating this workshop, which of course I jumped right into and was very glad. So this summer was very busy with that. And yeah, it's been amazing because you get motivated in doing stuff. I wouldn't have learned as much as I did if I just didn't join this community. So it really gave you a push, and to see so many interesting topics come up, not only in graph neural networks, but a lot of different topics, especially in NLP, something that I'm also interested in. To have ACE present the BERT paper in the next week after it came out immediately, and the OpenAI GPT model immediately after it came out. So it was also cool to see to be part of this community that was presenting the leading edge research, within just a couple of weeks of it coming out. Yeah, so I've been enjoying it, learning a lot more, and yeah, and meeting a lot of like-minded people.
Right. It's not just a great group of people, but also cutting edge. I appreciate that point. Maybe before we break out, I'll just ask you to speak for a minute or two about the course that you're running right now, in case anyone here would consider taking it. Could you give them a sense of what to expect?
So basically, the course goes through the basics of running graph neural networks. It's not very heavy on theory, but it does cover some basics, so that if you were to read after you finishing the course, if you were to read some new paper, you would understand the steps, and also a lot of practical examples and exercises that go along with the course material. It's all meant to be just there are videos, but it could be just covered using the notebooks. So the Colab, everything is in Colab, including the explanations. So you can just read that. Everything is self-contained in the notebooks, which was by design. And yeah, it's not easy at all. So you have to put in work to finish the assignment, but it's not extremely hard. So I think it's the right approach. If you have a knowledge with in PyTorch, right, framework, or TensorFlow, but and you have done some deep learning before, it should be an enjoyable course to go through. And there are lots of other references that are given out in the course if you want to delve deeper into other topics.
Okay, that's great. Thanks for giving that overview. I will mention one thing, that people who have participated in these capstone projects, some of them have been offered large sums of money for their ideas. So that's another thing to consider as well. But I wanted to ask each of my panelists, maybe starting with Nausheen, if there is a learning resource or a particular approach or something you recommend for people who are particularly interested in graphs and are just getting started.
I think there are many tools out there, like Python libraries, which have like basic graph visualization and graph analysis tools. So like Network X is there. One of them is iGraph. So they try to, like, you can do simple analysis like centrality or community detection kind of things. But going further advanced, especially if you want in an NLP knowledge graph scenario, if you want to try. So there are many open data sets which are available on which actually the academicians do research, and it has kind of become a benchmark. So simpler ones like WordNet is there, so you can start standard techniques on a WordNet or a Freebase or a Wikipedia data set. So you can first take some data set which is standard, um, which is used across the community, so that you have something in common with the community, and then you can start with some problems, or a knowledge graph embeddings approach. So there are many tools for finding, particularly for embeddings. So there's this PyTorch big graph library which can be used, or Amazon also has a knowledge graph embeddings libraries, so you can try that. So there are many open source things which are available to just start. Mhm.
Great. Nabila.
Yeah, so actually when I started 8 months ago, that was a really good question because there were no like books or resources. The first thing I got into when I got into ML was I read the Keras textbook. Open it, Jiri. I read the Keras textbook and it was really useful. I didn't finish it. I'm not the type of person to finish a book ever, but this is a good book that I recently started reading, and I think I got to chapter 5, 6, 7, the second section. Came out recently. It's by a giant authority in the field. It's a really good like starting point. I think the hardest part with GNNs was understanding how to wrap your head around it. Like convolution is one thing, graph convolution is it's like a little different. Not really, but it took me some time to wrap my head around it. And the visualizations in some of these like blog posts was good, but I didn't have like a story start to finish. And this is kind of like one of those good start to finish stories. Although I haven't finished it, so I don't know how it ends. But I think it's a good resource to get started in the field.
Which book was that?
It's actually in the chat, right?
Yeah, I just posted it in the chat. It's by Will Hamilton and his group.
Oh, yes. Yeah.
There's another one, I can't find it, but that had a good section on scalability. It was by somebody at Amazon. I'll try and find it and post it here.
That's great. Great. Thanks. Kareem, your suggestions in terms of learning resources?
Well, learning resources.
Workshop.
The workshop, yes. So that's number one learning resource, workshop. Also, there are, if you just want to follow a lot of videos as well in an academic setting, there's the Stanford Machine Learning on Graphs course. It's available on YouTube, the entire lecture series. And there's also PyTorch Geometric. It has tons of examples, right, of using different graph neural network algorithms, and you can look at the closest example that you have to your own application and try that. And of course, there's also just normal standard material about graphs. Sorry about that.
It's okay.
Fine.
So there's also standard material about graphs as just a computer science topic. I learned personally before getting to graph neural networks. My path to graphs was, during my PhD, I was solving fluid flow through graphs, right? So when I was writing my paper, I looked at the book that here is showing, graph theory book for notations, right? And I was using Network X to build my graphs. So Network X is a very standard graph library as well. So if you're just doing a standard graph algorithms, that's a very nice and easy to use library to do. And it has some, algorithms that may work for your top problem without using any deep learning. So, check that out as well. And after that, I learned mostly through lectures, papers, and PyTorch geometric library examples.
Okay, that's great. Thanks, Nabila. Tell us about the link that you've put into the chat.
Oh, sure. Michael Bronstein's another authority in the field. He's heading up the Twitter graph representation learning group, and he's recently started blogging, and his blogs are great because he draws his own diagrams. Like I asked him, where do you get these? And he's like, I draw them on my iPad.
I saw that actually. Go on. Sorry, go
Yeah,
on.
they're really great. I was really jealous because like making them in PowerPoint is one thing, and like Kareem knows, like we struggle making them for the workshop, but he draws them by hand, and it's a very nice visual perspective on the field, and so I enjoy his blog posts. And he also talks about some of the heavier theory that doesn't get talked about. Like people kind of gloss over it, like the WL algorithm, which I can't attempt to say. It's like some German name, but it's a good blog post to follow, and his students as well share his articles. So like you'll see it on LinkedIn somewhere. It's a good guy to follow for top tier research.
Yeah, that's great. Thanks. I actually, when I was promoting this evening's event, I was Googling and looking for illustrations because I didn't want to use the same old picture every single time. And I found his posts, and I thought, I can't just take that. Like it's not in the public domain. But anyway, we've got some really great questions that have come up in the chat as well. So I wanted to make sure that we got to some of those. One of them in particular was the question of what sort of problems are inappropriate for graphs and when you're trying to solve them. And I'll see if any of you has something to speak to on that point.
Kareem, you're the pro.
Yeah.
I think the case where that would graphs leverage connectiveness in your data set. So if you have a situation where your data set, your nodes in your graph are not connected, they're isolated on their own, then you wouldn't be able to leverage any sort of GNNs to help you with that because they rely on connectiveness to do the message passing steps and stuff like that. So I'm trying to think of a scenario in a data set of that. Maybe a really sparse data set. I'm not sure. But if you ever run into that scenario, like if you were to plot out your graph and see the nodes and edges and you see that there's a lot of isolated nodes, then you're not going to get any benefit from a GNN.
Yeah, that makes sense. I've got another question in the chat, and this is from Amir, and he's my boss, so I need to make sure that I ask his questions. And the question is, what should I search to find techniques to identify graph nodes that are the same entity? An example being RBC and Royal Bank. Kareem, do you have thoughts?
This is a Nosheen question.
Okay, thank you. Nosheen, please.
Yes, exactly.
So in our work, what I wasn't trying to, in my previous work where I was trying to solve this problem, I wasn't trying to use graph or leverage graph to resolve the identity of the nodes, but we were starting from the text itself because we were building the knowledge graph from scratch. So there we were using the strings themselves first, and we were just using sequential networks of like pairs of similar or equal entities without using the context, just based on the strings, how it is written there. And we had like ground truth data for that. Like we had like pairs of data labeled that, okay, this is equal, this is equal. But yeah, I mean, when you use but when you already have a knowledge graph and you have the neighbors or things which are defined, then it's a completely different problem when the graph already exists. So there I think there are approaches which are called knowledge which is what is called, it's called entity alignment or something. Yeah, thing which we were discussing, Nabila.
Yeah, she and me were discussing this problem the other day.
So I haven't done that, but yeah, I mean, it's an existing problem. So let's say you have a LinkedIn knowledge graph, let's say, and now you want to link the same thing in an open source knowledge graph like a DBpedia knowledge graph. So how do you do that? So that's a different problem where you have like two different graphs and then you're trying to align the entities of both of them. So that's a different problem. And then within the same problem, maybe, I don't know, maybe using the embeddings of the graph itself, like if they are too similar, if they can be seen as a same. So yeah, I haven't come across a problem where I'm identifying from within the graph or using the graph itself to disambiguate it.
Okay. I had a broader question just about difficulties or challenges, things specific to working with graphs or graph neural networks that are particularly hard or specific to working with graphs. So maybe I'll start with Kareem. In your experience in production or when you're working with graphs, what are some of the things that can come up that people need to watch out for?
Oh yeah, so one thing that is quite challenging to do to implement properly is that you can always have new data points, so new nodes on being added to the graph during runtime, right? And you need to be able to deal with that. So for example, the simplest way is, you have a new node, you need to find it's, connected to other nodes that were already there. If it's a time-dependent problem, you probably need to have edges, directed edges to capture the flow of information properly. So you need to adjust the graph in real time, right, as you get new information. So that is one challenge from at least in a dynamic setting where your graph is changing during production.
Okay. Nabila, I wanted to ask if within the realm of research and development, are there particular issues or challenges that have come up in your work with graphs?
Kind of. So one of the problems we have right now is our graph is so dense that passing the messages is not going to help you differentiate nodes. If that makes sense. Like there's too many types of nodes. So trying to pick the graph data model to model our data set, like it's not necessary that if you have a record of SQL, like of tabular data, that every single one of them has to be a node. It could be that you consolidate some of them. It could be that some of them become a feature of another node. So the data model I have now is not the smartest, and for that reason, I have way too many nodes. And the problem is every node is a different type of node, and so kind of what Aushin was talking about the homogeneous graphs, and you have only one type of node in that graph, or you have heterogeneous graphs where you have multiple types of nodes in that graph. And so I'm in the second bucket where I have so many different types of nodes, and there's so many of each of those types of nodes. So I'm finding that's a little bit of a challenge to train it. And I've heard that graphs have the scalability issue when you get to a large scale of edges. I'm not there yet, but I think it's a problem I'm going to run into at some point. And I'm going to have to dig into the literature because this is one of those well-studied problems that everyone's trying to solve. So I think this will become a problem like the scalability issue.
Right. Okay. Nasheen, could you speak to any issues or challenges that you've run into working with graphs?
Yeah, so one of the things which you mentioned, that where you should not use a graph problem. So what our company is, we are a research consultant. So where the other companies come up and they give their data, and then they ask us to solve a problem. So one of our clients is Resolver. So they have data which can be represented in a graph, but they don't give their entire data, and they give a very small snapshot of data, and they expect us to give a prototype or something. So there we end up uh, in a lot of data which are not connected, and we are trying to solve a graph problem. So we can't scale the solution or show them the actual capability of using the graph in this. So yeah, I mean, that's one of the challenge, the lack of data. Another challenge was in my previous company, we were trying to build a knowledge graph from scratch. So there we were using like from text to triples when we were trying to convert. So we were using certain, like many open source tools which were there to convert a sentence into triple forms, where you triple, like node, entity, and like no entity, relationship, and another entity. So when you use an open source tool like OpenIE or Clause E, so they don't really scale into a domain specific problem. They are trained, or they're developed for general purpose data set, English, on English language. But when you come in a certain domain where your language is different and the grammar is not proper, so using such open source tools to extract the nodes and relationships was hard. So yeah, I mean, that cannot, and obviously whatever tools which are there, it has its own accuracy. They already are not like 100% foolproof which are there. So it's already at a lower accuracy, and then you're trying to apply it in a different or a very specific domain, then the accuracy is even lower. So yeah, that's a challenge, I would say.
Okay, great. Thanks. I think I have maybe one more question before we break out into some different rooms to continue the conversation. And this, maybe we could call this the science fiction question. Based on the work that you've done in the field and your knowledge of the research, where do you think graphs are going? What do you think is the future of graphs in machine learning? And I'll ask each of you for your thoughts on that, maybe starting with Nabila.
Ooh, I think I need a second to think about that.
Okay, well, maybe we can start with Kareem maybe then.
Wow, that's so purely science fiction, right? So I can speak complete.
Absolutely, forward-looking.
Forward-looking. Okay, I mean, since everything in the world is interconnected in some way or the other, right?
Oh no.
Oh, that was your. I can let you finish that.
No, I'm kidding. I'm gonna Google it.
I mean, and the power of heterogeneous graphs, right? That allow you to have nodes which in a graph which are of different types and edges that are of different types, right? You can have a large model of the entire world, where you can use whatever model to pre-process every node, whatever to embed every node, whether it's a person, a computer, a fridge, a microwave, an ironing board, whatever, and you have all these connectivities, and you can do whatever predictions you want on that. So that's a massive undertaking. But on a more serious note, you can have like basically expand the capabilities of existing machine learning models, right, by integrating different models, right, different specialized models, right, and using the connections between the things that they're trying to predict, right, to improve connections. So I think also having a meta model that's built using this graph neural network architecture to link different disparate models would be a cool direction to look at.
Yeah, maybe even for interplanetary communication at some point. I never know. Nasheen, your thoughts on the future of graphs in machine learning?
I think, I mean, currently, whatever we are doing, I mean, it itself has a lot of scope. So I think it's an ever evolving domain. So one of the things, maybe like temporal connections, like let's say uh, till last month, maybe Trump was the president, and now you have a newer president. So how do you capture oral information and update, or kind of like in a dynamic environment, how the graphs should work? I think that can be one of the challenges, or problems which needs to be solved or which is already being solved. Other than that, I think there are many other problems, like one of the things which you are also mentioned in our agenda was like of bias in a graph. So we'll discuss that when you ask.
I'll ask now, actually, then. Just a topic that people are talking about a lot right now is the issue of bias in machine learning. And
Yes.
if you have thoughts on that specifically within the graph realm, I would love to hear it. Yeah.
Yeah, so I think uh, bias has been a popular topic of research recently, but I was saying that, in knowledge graph area, it's still pretty new, where the research is still pretty fresh. So I came across one of the research by Amazon, where they're just saying that, there is bias. So there is bias, like so there can be a majority of politician person which are males. So that doesn't mean that, all the politician has to be a male. And if we are doing some fact checking kind of a task, like we are giving that, okay, whether this fact is true or false. So it shouldn't be that if you are putting a female's name like Jacinda or something, it shouldn't be that, okay, it's very unlikely that she's a politician. So that's one of the, I think, upcoming research in terms of graphs here.
So I just wanted to say, wrap things up quickly, because I know there's a lot of different things that you could be doing on your Tuesday night. And we really appreciate that you've taken the time to participate in the group and in these conversations with us. I want to thank my amazing guest speakers, Nabila, Nashin, and Kareem. And just a quick reminder as we wrap up, that you can get more content like this at ai.science, our website. You can go to LinkedIn and add Aggregate Intellect. I recommend it. So you'll be hearing about stuff all the time. You can get those same updates through Facebook or YouTube as well if you join ML Papers Explained. So I'll just wrap it up and say thank you so much, everybody. Maybe my speakers could stick around for a minute or two, but thanks a lot for joining us tonight, and hope to see you at our next event in this series on bias in machine learning for newcomers, which will be in mid-December. Okay, thanks everyone.